All right, so we're dealing with functions today, and this is one of the most important things that you're going to learn in Algebra 1 because you'll be dealing with functions a whole bunch in Algebra 2. I'm teaching pre-calc this semester. My pre-calc students are about to take a huge test. It's all about functions. We're just going to get kind of used to the idea of a function today and learn some new notation. I'm going to tell you, you're going to see some notation today that's going to look strange to you. Kind of like when you read a word in another language and it just doesn't look like a real word. I want you to think of this notation like just another language. You're going to get used to it because we're going to use it a bunch. Okay, but it is going to look strange to you at first. All right, so here's the big idea. A function is kind of like a machine. I usually like to draw a little box with an arrow going in and an arrow coming out. Lots of machines like this you'll find in a factory. Something goes into the machine, something else comes out the other end. Right? A whole bunch of steel goes in one end, bicycle comes out the other. Cow goes in one end, hamburger patty comes out the other. All right? Yeah, and then it gets really weird when we start running machines backwards and turn a hamburger patty into a cow. But you'll get to that in Algebra 2. We've got an input, and then something's going to happen on the inside. But this is a math machine. So the thing that's going to happen on the inside is going to be some kind of equation. So my first example is going to be this. I would like you to write f parentheses x equals x squared plus 1. Now this, I'm going to make myself a little speech bubble here. We pronounce this f of x. How many people have heard that before? F of x. A couple of people. So for most of you, this is the first time you're hearing of f of x. You're going to hear f of x, f of x. It's going to be all year long. Sometimes we do g of x and h of x. We're going to stick with just f of x's for right now. And it really means function of x. All right, and what we're going to put into this machine, let's start pretty simple. Let's put in x equals 3. And let's see what we get out. So I want you to think, and please don't shout out answers. What would happen if you put 3 into this equation, x squared plus 1? If you put 3 in for x, think through that. What would you end up getting? Can you do that in your head? What I'd be doing in my head would be 3 squared plus 1, which is 9 plus 1, which is 10. That's what's going on in my little thought bubbles for this. So my final answer becomes f of 3 equals 10. All right, so the whole idea is you get an equation. I give you an x value, you plug that x value into the equation, and you write down the answer. But the answer is going to be kind of in this weird function notation. All right, some of you are going to be sitting there right now thinking, oh, this looks weird and complicated. Just bear with me, okay? We're going to get you comfortable with this. The thing that's making this feel complicated to you is that it looks strange. It's a different language than you're used to. Okay, trust me when I tell you this is not a difficult thing to do. It's just kind of difficult to get over that hurdle of this looks different from what I've seen before. Okay. Can you let me know if you have a question or a comment? Just put your hand up and I'll call on you. Okay. I'm going to go on to the next one and we'll come back to you in a sec. Okay. I want to get a couple more examples done because I want to make sure that people are feeling comfortable with this. Off to the side here, can you rewrite that f of x equals x squared plus 1? We're going to next find f of 5. And what we're doing is we're just taking that same machine, because it's the same equation, and we're putting a 5 in instead of a 3. Okay. So let's show our work right here. This is how we would show our work for this. We would rewrite our equation without the x in it. And what number do you suppose we're going to put in place of the x this time? 5. Yeah. We'll do a little math. Some of you will be comfortable doing this mental math in your head. Some of you will run right off your steps. That's 25 plus 1. 25 plus 1 is 26. So f of 5 is 26. Let's do another one right underneath that one. Let's do f of 2. Oop, I should have put a box around that. That's our final answer. F of 5 is 26. We're doing f of 2 now. I challenge you, see if you can tackle this one on your own. Try to do what we just did, except this time we're using a 2 instead of a 5. Same equation. If you need a hint, go ahead and look up at the screen. How many people were able to come up with 5? Ooh, look at you guys. Okay. All right. So you get the idea what we're doing here, right? What we're doing is we're putting a number in for x, and we're coming up with an answer. You've actually been doing this in most of your homework assignments, right? It looked different though. It didn't have this f of x thing. That's kind of the new thing. All right, we're gonna switch things up on you and see how we do with a little bit of a curveball here. I'm going to move down my page a little bit. I'm going to write a new function, f of x equals 2x. All right, so I've changed my machine. This is a different machine. It's doing something different to the x value. And I am going to challenge you to please try and find for me f of 10. If you need a hint, I'm going to be working it up on the screen. Let me write this down. When we see a number and a variable next to it, what's happening? Is that addition, multiplication, division, multiplication? So 2 times 10. How many people were able to get f of 10 equals 20? All right. Can you show me on your thumb here how you're feeling right now about this whole f of x business? Are you feeling? Ooh, we got a lot of people in the kind of trending upwards at least. Okay. Awesome. Awesome. Let's do one more. Same equation. We're still going with this version of f of x. Could you please find me f of -3? Same equation. So we're still using f of x equals 2x here. We're putting a different number in for x this time. This time it's a -3. Okay, how'd you do? You get -6? Okay. All right, so usually when I show my students this the first time, they're like, whoa, hang on here, what's this f of x business? But you're getting the idea that basically all we're doing is I'm giving you a number to put in for x. Okay, awesome. So I'm going to ask you to please open your books up to page 26. We're going to do problem 55. And I'm going to get you started. We'll do part A together, and then I'm going to ask you to work through parts B, C, D, E, F, G, H, I. Don't you love how this textbook always has like 18 different parts to every problem? All right, problem 55. We're going to work through part A together. Now, they're going to give you kind of a big old function machine looking thing. Arrow going in, arrow coming out. You don't have to write all that. I'm going to show you what you need to write for part A. Just go ahead and write down what it says the equation is. F of x equals negative 2x plus 4. That's what it says inside the machine for part A. And in the picture, what is it showing? What number is it showing going in for x in the picture? So for part A, they're showing negative 3 going into that equation. So I'm going to put, we're going to do f of negative 3. So we'll work through and we'll do the same steps we did a minute ago. Are you comfortable with how I translated that picture into a problem kind of similar to what we just did? Are we good with that? All right, so my equation now is negative 2x plus 4, but I left my x out. And I'm going to replace it with the value of x they gave us here, which is negative 3. And then we're going to do a little work. We got multiplication and addition. Order of operation tells us we need to do this multiplication first. Be careful with your negatives. What happens when you multiply two things that are negative together? You end up with a positive. And then now we can deal with the addition. 6 plus 4 is 10. Final answer is f of negative 3 equals 10. So that's what you're going to do for each of these problems. I do want to see, I am not interested in you just writing answers. I want to see the steps. Now, if you want to do this mental math in your head, that's okay. You can leave out the part that's underneath my pen right now. But I need to see this step right here. Okay? Is anybody curious why I'm going to force you to show that step? Some of you are going to be like, I can just do this in my head and tell you what the answer is. Anybody curious why I'm having you write this step out? What do you think? I want to see your thought process, yes, but there's a different reason why I'm doing it today. On a test, that's absolutely the reason. The reason I'm asking you to do it today is you learn better when you write out your steps. You're thinking about it, that's one way of dealing with it. You're also writing it. If you have any questions, I want you to talk about it with your neighbors. Now you've got a third way. Brain science says the more different ways we interact with something, the longer we remember it, the better we remember it. So that's why I'm going to ask you to write out those steps. So if you could, just go ahead and finish up 55. If you get done with 55, go ahead and have a look at 56. We're going to come back together and talk about 56 in a moment. Go ahead and stay in your assigned seats for right now, but I am totally okay with you spying on a neighbor's work. Okay, that's not cheating when we're learning, right? It's okay to look at someone's work and say, I'm not too sure what I'm doing here. Let me get a glimpse of yours and use that as a hint. It's okay to ask a neighbor for help. It's okay to check in with a neighbor and see if they're getting the same answer. It's okay to offer a neighbor a help, to say, hey, are you doing okay with this? Can I help you? It is not okay to be having side conversations that are not about function notation. Okay. All right, get after that, and we'll come back together here in about, I think probably 5 or 6 minutes should be sufficient here. We're going to do all of problem 55. So there's 9 altogether. I'm going to put some answers up here. If you didn't get to all of these, that's okay. I want you to check the ones that you did. For part B, did you end up writing f of negative 2 equals 1 for your final answer? By the way, that is the answer. It's not just one. It's f of negative 2 equals 1. So make sure you're writing that whole piece. For part C, did you have f of 5 equals 125? Part D was tricky because they asked you to take a square root of a negative number, and we can't do that. So part D, we could write undefined. If you wrote for part D like not possible or can't do it or something like that, that's fine. But we can't do that for now. We will learn about how to take square roots of negative numbers in Algebra 2 for those of you who take Algebra 2. For E, did you have f of 2 equals negative 5? For part E, f of 2 equals negative 5. Sounds like maybe we want to go over that one. Okay, we'll go over that in a moment. For part F, they kind of switched it up on you. They told you that we wanted to get 99 for an answer, and they were asking you to figure out what we need to put into it. I bet a lot of people came up with 10. Did anybody come up with negative 10 also? Good for you. Convince yourself that negative 10 would work. Look at the equation for part F. The equation for part F was x squared minus 1. What happens when I square a negative number? When we multiply a negative number times itself, it's going to turn positive, right? So negative 10 times negative 10 would give you 100, minus 1 would give you 99. So both of those would work. If you came up with 10, I am super happy. Okay? If you came up with negative 10, I'm really impressed. Part G was not possible because you can't get a negative number out of an absolute value. It just can't happen. Part H and I are up here. Part H was f of negative 4 equals 6. Part I was f of negative 4 equals 2. We are definitely going to go over part E. I heard a couple moans and groans. We were looking at part for when I give you the answer for part E. So let's do this one together. There's fractions in it. F of x equals x plus 3 over 2x minus 5. This is where you really want to write down. This is why we want to write down our work so we can work through this one piece at a time. This is part E. So when I gave you the answer, it sounded like a lot of people didn't get that one right. That's what I was anticipating. This would probably be the most missed one. So let's see if we can work through this. I'm going to rewrite my equation. I'll leave out all my x's. And what am I going to replace my x's with? 2. Now I need to go through and simplify this. On the top, I've got 2 plus 3. On the bottom, I have both multiplication and subtraction. PEMDAS tells us we need to do this multiplication first. 2 times 2 is 4. And then we'll do the minus 5 after. And I would do this in 2 separate steps. 4 minus 5 is negative 1. When we divide something by 1, it stays the same. But when we divide by negative 1, it's going to flip the sign on it. So that 5 divided by negative 1 is going to give us a negative 5. Were there any others you wanted to talk about? All right, so we have our first test coming up here in about a week and a half. And you're going to see some problems that are going to look like this one that we did in our notes. I'm going to give you an equation for f of x, and I'm going to ask you to find f of 10 and f of negative 3. And I think you guys are going to do really well on it. You'll see these pop up in our homework assignments over the next couple of assignments. Speaking of which, go ahead and get our new assignment copied onto the back of your packet here. And my expectation for remaining time is that you're working on the homework assignment or asking me questions about what we did in class today. This is all on the very next page of your textbooks. You've got your books out. You can go ahead and get started on this. We have, until we pack up, we got about 12 minutes. I don't want to see people packing up for the next 12 minutes. I'd like you to be working on this assignments. Okay, for those of you who have fallen behind, stop recording. The internet doesn't need to hear this.